Welcome back, my dear students. Welcome back. All welcome, beta. Please confirm me, everyone, beta. Audio and video is crystal clear to all of you. Can we start today's session? Very happy good evening, beta. Inamul, Shushmit, Nandi, Ayush, everyone, beta. स्वागत है आप सभी का. You're all welcome. You're all welcome, beta. We will wait for a few seconds. After that, we will start today's lecture. Few more seconds, beta. Students are joining. Wait, beta. Okay, now I'm able to see your comments. वेरी हैप्पी गुड इवनिंग बेटा क्यादाश महना सभी का स्वागत बेटा यू आर ऑल वेलकम ओके बेटा सो कैन वी प्रोसीड वन मोर टाइम प्लीज एवरीवन कंफर्म मी ऑडियो एंड वीडियो इज क्रिस्टल क्लियर टू ऑल ऑफ यू एवरीवन इज रेडी फॉर दिस ब्यूटीफुल लेक्चर नंबर 6 यस सर ओके बेटा so today basically you will see details of reaction rate constant as well as activation energies, and if time allows then also you will see details of Arrhenius law. Otherwise Arrhenius equation we will discuss in our next lecture. Okay, and also today I will show you from just these fundamentals how much 1 mark questions already asked in your PYQs. Okay, so some questions I will show you today. In a previous lecture you had seen classification of multiple reactions and classified as parallel reaction, series reaction, Dunback reaction, and independent reactions. So my dear students, first one, please write down everyone parallel reactions. So क्या होती है parallel reactions? So first thing beta, it is also known as competing reaction. It is also known as simultaneous reaction. Why competition is there? What is the meaning of competition? See, reactant A, reactant A, it is going to form R as well as it can form yes. So see, same reactant is going to consumed by two different paths. Definitely for both paths the value of reaction rate constant may be different. Okay, a physical example if you want to take, then suppose you are going to burn methane. So methane plus 2 O2, it is going to give you CO2 plus 2S2. At the same time, my dear students, this methane can also form carbon monoxide, that is CH4 plus 1.5 O2, and that becomes equals to CO plus 2S2. So beta, when you are seeing these type of reactions, these are known as parallel reactions. These are known as parallel reactions. Now here you can see beta their definition. In parallel reaction, the reactant is consumed by more than one reaction path to form different products. Okay, so nothing special. I hope everyone feeling comfortable with this one. Very happy good invitation there. So please everyone tell me, can we proceed? Can we proceed better? So this is known as parallel reactions. Now, very good. So next one is better series reaction. Now, what is series reaction here? What is series reaction? Now, just as you had seen in parallel reaction. So different products are formed by different paths. But when you are going to check for the series reaction beta, in series reaction, suppose you want to make R or yes from A. So first is A will give you some intermediate product R, and then that intermediate product further by further reaction is going to give you final product yes. So these type of reactions are known as series reactions. These type of reactions are known as series reactions. Here R is your intermediate product. Intermediate product. R क्या है आपका? Intermediate product है. And for this given case, my dear students, this S is your final product. S is your final product. Now you can see definition in series reaction. The reactant first form an intermediate product, okay, which then further react to form other products. So these type of reactions comes under category of series reactions. In your syllabus, details of series reaction is also there, details of parallel reaction kinetics, study of parallel reaction is also there. So we will see soon. This time still we are in fundamental, so just we are seeing their basic details, that what is series, what is parallel. And as you had seen, parallel reactions are also known as competitive reactions, or also known as simultaneous reactions. Similarly, here, beta, series reaction is termed as consecutive reactions. Consecutive reactions. For an example, if you want to take, then see, suppose you have methane CH4, and this methane is going to chlorination of methane. Reaction is known as chlorination of methane. So in first step, you will get CH3 Cl and plus HCl. H replaced by Cl here. Okay. Then again this CS3Cl further going to react with chlorine, and now this time it will give you CS2Cl2 plus HCl. Again, my dear students, this CS2Cl2 is going to react with chlorine, and this time you will get chloroform CSCl3 plus HCl. Again, this chloroform can further react with chlorine in order to give you carbon tetrachloride CCl4. So in series reaction, definitely final product you will not get before any intermediate product. That means first intermediate product will form. After that, that intermediate product again going to react with reactant in order to give you final product. Okay, it may be here chloroform, it may be here carbon tetrachloride. Okay, but any of these you can't form directly. Okay, any of these products you can't form directly. There may some involvement of some intermediate product is there. Okay, so please everyone tell me one more time, is it crystal clear? Can we proceed beta? Fatafat batate jo beta. These things are very very easy, so I don't want to consume too much time here. Just fundamental. So if crystal clear, then immediately write CC so that we can move forward, but immediately we can move forward. Okay, so next one is about a Dernbach reaction. Just I told you, in Dernbach reaction, A is going to form you R, as well as A can give you X. Again, this R can give you S, and same time this R can also give you Y. This S can give you T, and this S can also give you Z. So in this manner, if some reaction is going to occur, in this manner, if some reaction is going to occur, then these type of reactions are known as beta Dernbach reaction. Dernbach reaction. And everywhere I am giving already given example by me. So here this is your assignment. Don't worry. Every assignment question I will discuss in my live doubt clearing session. So this is your assignment. Very very easy assignment. But just search example and give me one example of Dernbach reaction. Okay, so this is your home assignment. Please, beta, everyone, don't forget to do these assignments. Very, very important. Okay. Now, next one is independent reactions. What is independent reaction? See, from its name, you are able to find information about independent reactions. Independent. That means they are independent. आपस में कोई मतलब नहीं. In Hindi, if you want to feel, आपस में कोई लेना देना नहीं reactions का. Like in parallel reaction, you had seen A is forming R, A is forming S. So the speed may going to affect each other. In series reaction also A, R, S, T. But in independent reactions, all reactions are independent to each other. So different reactant form different products independently. Like suppose beta, A is there, so A is going to give you R. Some B reactant is also there, this B is going to give you yes. Some C and D is also there, they are going to give you T. So independent. These reactions are independent to each other. A is forming R, B is forming S, C plus D is forming D, T. These are independent reactions. These are independent reactions. ये सारी reactions कैसे हैं बेटा? These reactions are independent reactions. Now please can you tell me, this time I'm not giving assignment, this time I want from your side in this live class, can you give me any example beta? So different reactant form different products independently, happens when lots of product present in the same feed. मतलब आपका एक ही feed है उसमें बहुत सारा product present है. Okay, in the same feed lots of products are there. So independent reactions happens there. Now please give me any example, any real example if you know better. Please everyone tell me better. Any real example if you know, then please tell me everyone. Any real example you know? Any real example you know better? I am waiting for your comments. Everyone please. Mm-hmm. I want comment from your side beta. If you know then please write immediately in comment section. If you don't know then just write don't know sir. Then I will give you beta. Please everyone tell me if you know any example. We are still waiting for your comments, my dear students. Any one of you? If you don't know that beta, you can write R in comment section. Immediately you can write R in comment section. R. Okay. Don't know. Okay, beta. Sushmit Nandi, I used to. No need to worry. Don't need to worry. You know crude oil. Crude oil नहीं पता आपको? You know crude oil. In crude oil, many products are there. Yeah. Thousand lakhs of compounds are there. Yeah. More than lakhs of compounds are there just in crude oil. So definitely in crude oil, different reactants are going to form different products independently. Is it crystal clear to all of you, my dear students? Is it crystal clear? Can we proceed, beta? Everyone, please tell me, can we proceed? Can we proceed? Very easy. Okay. Now, before moving forward, my dear students, one more thing I want to discuss with you. Okay, and that is undefined reaction order. That means can we define order for every type of reactions? क्या ऐसी possibility है कि हर एक reaction बेटा please one thing don't worry if I am telling anything in Hindi that means that just a translation of my previous line or my next line, so don't worry English learners who don't know Hindi. Okay, just I'm using some Hindi for Hindi learners feeling. Okay, so my dear students, suppose you have a reaction and I am telling that for every type of reaction you are able to define order of reaction. क्या आप हर एक तरह के reaction के लिए order को define कर सकते हो? So my answer is no. My answer is no. You can't define order for each type of reaction, every type of reaction. Like, see, one thing you will see in this, because that is in your syllabus, that is heterogeneous reaction system. Heterogeneous reactions. And but this is just a typical example. That means in if reaction is not heterogeneous, still it is possible that reaction order you will be not be able to define. आप उसके reaction के order को define नहीं कर पाओगे. Okay, so suppose our reaction is there, like, see, Ra is equals to K, K1, K2, CA, CB. Just typical uh, rate expression I am writing here, beta. K1 CA plus K2 CB C and whole square. How you are able to define its order here? Order कैसे define करोगे? Concentration dependent term is present in numerator as well as in denominator. K, K1, K2 are reaction rate constants. So definitely for this reaction you can't define order. आप इसके लिए order define नहीं कर पाओगे. Order is undefined here. Undefined here. यहाँ पे आप order को define नहीं कर सकते हो. Okay, is it crystal clear to all of you, beta? Is it crystal clear, my dear students? But for these type of reactions, if you are considering some special type of case, then only you can define order. Like previously you had seen when reaction rate what is the order when concentration is very high, when concentration is very low, azomethane pyq, जो हम लोगों ने एजोमिथेन का पी वाई क्यू किया था. आई होप एवरीवन रिमेंबर्ड दैट पी वाई क्यू. सो वी कैन डिफाइन बट can't directly by assuming something. Like here if you want to define, then you can define like by assuming that concentration of A is equals to concentration of B. How? Suppose if I am telling, please define. So by assuming CA is equal to CB, and also by assuming that CA and CB both are same, so both are available at very high concentration, then can we approx this? या क्या इसको अभी हम लोग approx कर सकते हैं? चलो देखते हैं. Let's check that we are able to approx it or not. So if CACB is first thing, CACB is same, and also you have to write that K1 is also equals to K2 here. So if same, so here you can write just like KCA, 2 KCA, 2 KCA, and 2 KCA plus 1, that means nothing. That means nothing here. 1 is very, very small in comparison to 2CA, 2 KCA. Okay. So here you can write now RA is equals to all K, just write like K dash in the numerator, and CACB just you can write like CA square. And in denominator now you can write beta just like 2K, 2KCA. And now whole square is also there. Whole square is also there. Now see beta, clearly you can see it's K triple dash, you can write triple dash is K dash upon 4K double dash square. And CA square cancelled. That means your CA raised to power 0. For this given case, the order is, if I'm asking the order of the reaction, this is 0. For this given case, for this given case. Okay, so you can give, but that doesn't mean that is it is defined there. You are defining only by assuming something. You are defining only by assuming something. Okay, so please everyone tell me this small note is crystal clear to all of you. Can we proceed बेटा? क्या हम आगे बढ़ सकते हैं? फटाफट बताते जाओ बेटा, because we are still in fundamentals, still the main part or portion. You can't start off CRE before knowing these details of CRE. जब तक इन डिटेल्स के बारे में CRE के नहीं जानोगे, you can't be able to start it. Okay, so please tell me everyone, this one is also crystal clear, and lots of PYQs already asked just from these basics. Crystal clear, sir. Okay, fantastic. So my dear student, next is reaction rate constant. Already we discussed a few things about it. Now little bit detailed, I want to give you little bit detail of this reaction rate constant. So before moving forward, everyone know that the other name of reaction rate constant. Please tell me beta. I told in my previous lecture. If you know, then please. If you remember, then please tell me. Please tell me. Waiting for your comments. Everyone, please tell me beta. Is there any other name for rate constant? क्या कोई और भी नाम है rate constant के लिए जो आप इस्तेमाल करते हो? Everyone, please tell me. If you know, then please tell me. Still waiting for your comments. If you know, then please tell me. किसी को पता है क्या? नहीं सर. I told you ना velocity constant भूल गए बेटा. I told you na, reaction rate constant is also known as velocity constant. Velocity constant. It is also known as velocity constant. This is you can say synonym. Synonym word that you can use to represent reaction rate constant. Okay, so this is nothing but synonym. Now, you had already seen in my previous lecture that when you are going to write reaction rate constant RA, then in that RA, two terms are there. It is a function of two terms. One term you had seen, temperature dependent term, temperature dependent term, and the second one beta you had seen concentration dependent term, concentration dependent term. In short, you can write like RA. Any reaction rate is going to depend upon temperature because of their reaction rate constant. So further I can write it like K into function of concentration. K into function of concentration. Now, in this representation, this reaction rate constant K, small k, this reaction rate constant is small k. This is your temperature dependent term. This is your temperature dependent dependent term. How you will see in my subsequent lectures. Here just I am showing you your future lecture, few lines, like you will see according to Arrhenius, this K can be written as K naught e raised to power minus EA by RT. EA is activation energy, T is temperature, K naught is frequency factor or pre-exponential factor. So you will see details about this reaction along with graphs, its dependency, its sensitivity, everything I will show after some time. Okay. This time I want to tell you something about reaction rate constant, about its unit. अभी उसके unit के बारे में पहले हम लोग देखेंगे. After that, its dependency according to Arrhenius, and a few more laws are there, like collision theory, like transition state theory. Everything we will deal in discuss in detailed manner. We will discuss in detailed manner along with lots of new questions and PYQ. So don't worry about this. But अभी के लिए इसको भूल जाओ. Just you can see from here that K is a function of temperature. See, K is a function of temperature. See, this K is a function of temperature. So this K is a temperature dependent term. Either you are going to represent by Arrhenius or collision or transition state theory. It doesn't matter. In everywhere, this E raised to power minus E by RT term is there. Okay, and few extra temperature term is there in case of collision and transition state theory. I will show you after some time, or maybe in my subsequent lecture, not in this lecture, in next lecture. Okay, so here my dear students, K is our temperature dependent term, and this temperature dependent term is known as rate constant. Now here you can see with the help of this Arrhenius equation, जो Arrhenius equation अभी यहाँ आपने देख ही लिया. अगर देख ही लिया है तो एक चीज और देख लो यहाँ. Just focus here, my dear students, that clearly this K is a function of temperature. K is a function of temperature. But wait. This K is there anything that we also can change by changing some condition there? Yes, see. Out of this equation, you can't be able to change this K naught. इस K naught को आप change नहीं कर सकते. You can't be able to change this R. आप इस reaction rate जिस universal gas constant को भी change नहीं कर सकते. You can't be able to change this the value of universal gas constant by changing temperature or anything else. Okay, but wait. You can change this EA, this activation energy. But better wait. This activation energy is clearly not a function of temperature. It must be crystal clear in your mind, beta. You can't change activation energy of a given chemical reaction by changing its temperature. आप temperature को बदल के activation energy को नहीं बदल सकते हो. But still, I am telling you that this K is not a function of T alone. It is also a function of activation energy. Sir, then you have to write like it is a function of R also. No. Why? See, this activation energy is fixed. But wait. We can change it. We can change its value by changing or using catalyst. If no catalyst is used in any chemical reaction, then just use some catalyst. Yeah, then just use some catalyst. If no catalyst is there, then use some catalyst there. ये changed. If already some catalyst is there, then change that catalyst. Again ये changed. But if you are not changing catalyst, like suppose I'm writing K is a function of temperature only. When for a given reaction with or without catalyst, जो भी आपका दिया हुआ है, That means you are not going to change catalyst, or now you are not going to use catalyst anything. The reaction mixture is there and you are not going to change it. Just you are changing temperature, etc. Okay, so in this case ea is fixed. In this case ea is constant now. In this case ea is a constant now. ea constant ho gaya. So in that case you can write k is a function of temperature only. But if you are going to change the catalyst, see what I want to say. uh, you have some value of k for reaction. Suppose some reaction is there. यहीं पे लिख लो अभी. Suppose some reaction, see some example. Suppose some reaction is there, reaction number 1. Okay, it is happening at some temperature T1. It is happening at some temperature T1, and same reaction 1 is there. Again it is happening at same temperature T1. This time, my dear students, in the presence of catalyst 1, this time in the presence of catalyst 2, and if this time the value of reaction rate constant is K1 and this time K2, then it doesn't mean better that K1 and K2 will be same. Even temperature is same, but EA1, EA2, this is not same, not same. If this is not same beta, if this is not same, then my dear students, this is also not same. This is also not same. Even for same temperature. Even for same temperature. So see, if temperature is same, still the K value is not same for the same reaction. If we are changing catalyst, if we are using different catalyst, so for same temperature, still the activation energy is going to affect the value of this K. Okay, please tell me everyone, beta, is it crystal clear to all of you? Can we proceed, beta? Please everyone tell me, beta, can we proceed? No doubts at all. सब कुछ crystal clear? Waiting for your comments, everyone. Beta, please write. If you are feeling any doubt, any single percentage of doubt, then don't worry. Feel free to ask me. Feel free to ask me. If all clear, then please write crystal clear, sir, so that we can move forward here. Come on, everyone, tell me. Everyone, tell me, beta. No. Okay, beta. Very good. Crystal clear. Then it's great. बहुत अच्छे. Now, suppose I'm drawing again one diagram that already drawn by us in our previous lectures. Like this side, just I'm taking energy, and this side I'm taking reaction coordinate. Okay. Now, if this is reactant, and this from this line, I'm showing you the average energy of reactants. Here I'm showing you the average energy of reactants like this. Now, when I start providing energy, it looks like this. Okay, it looks like this. Can you tell me, beta, this diagram made by me is exothermic or endothermic? Because you already had seen endothermic and exothermic reaction diagrams. So please tell me, beta, this is exothermic or endothermic? This is reactant, this is product. So clearly here R is going to make P. Tell me, beta, everyone. Exothermic, very good, because product energy is clearly less, so heat is evolved there. Heat is evolved there. बहुत अच्छी बेटा, fantastic, mind blowing, super. Now see, if I want to show, then this is what? This is the value of activation energy बेटा, यही तो है आपका activation energy E, और you can write EA. आप इसे ऐसे भी रिप्रेजेंट कर सकते हो, E subscript A. एक्सोथर्मिक सर, वेरी गुड बेटा. श्यान मुखर्जी, सुस्मित, नीरज आयुष. बेटा आई वांट कमेंट फ्रॉम एवरी स्टूडेंट. सभी लोग कमेंट किया करो प्लीज. ठीक है, सभी लोग कमेंट किया करो, एवरीवन. ओके. नाउ this is exothermic reaction now, and this EA is your activation energy. And if this time I want to represent this energy, then this is not the energy that is above their एवरेज एनर्जी ऑफ, और यू कैन से एवरेज, अबव एवरेज एनर्जी ऑफ रिएक्टेंट्स। ये वो एनर्जी नहीं है जो एवरेज के ऊपर वाली, एवरेज के ऊपर वाली तो केवल ये है। दिस इज कंप्लीट एनर्जी दैट इज रिक्वायर्ड एट द टाइम ऑफ रिएक्शन। सो जस्ट एज आई ऑलरेडी टोल्ड यू बेटा, दिस इज ETH. What is ETS? EA is activation energy in this diagram. EA is activation energy in this diagram. Activation energy. Whereas ETH is, can you tell me बेटा what is this ETH? बताया था आपको ETH के बारे में, रिमेंबर है आपको, क्या भूल गए? रिमेंबर्ड? What is ETH? What is ETH? Threshold energy. Fantastic बेटा, threshold energy. Fantastic. And what is this बेटा, ये क्या है? Please tell me. What is this? What is this? This is ER bar and this is EP bar. So what is ER bar बेटा? What is ER bar? ER bar क्या है? What is ER bar? Average energy of reactants. Average energy of reactants. Soon I will also tell few details about this average energy, that inside this average energy which energy is present and how you are going to calculate it. For this time, this is average energy of reactants, and EP bar is average energy of products. And definitely for the definition of activation energy, ER bar is required. So clearly here, my dear students, you can make one beautiful relation, that is ER bar plus EA, and that will give you better ETH. Very easy relation. Very easy relation. Very good beta, very good, fantastic. क्या बात है भाई. Okay, so whenever a reaction is going to proceed, just focus here beta, important note written by me. For a reaction, two conditions must be satisfied by reactants. Already we discussed these things in my previous lectures. Okay, so I hope everyone remembered that thing. First one is geometrically properly oriented at the time of collision. Second one, they must have their activation energy. What is the meaning here? Again, I want to repeat. See, if this is your reactant and it is going to react with this some other reactant, and they are colliding like this, see, reaction not occur. Still reaction not occur. If they are colliding like this, see, reaction occurred. That means this time properly oriented. Okay, but maybe there is a case when still they are properly oriented collision, still reaction not happening. What is the reason behind it? See, here in this case beta, 1 and 2 both satisfied, so reaction occurred. But here beta, only and only first one satisfied, one is satisfied. Their energy is less than, total energy is less than threshold energy. Total energy is less than threshold energy, or you can say they have not their activation energy. So still proper orientation, no chemical reaction will happen there. Now, how catalysts are going to affect rate? For that case beta, first thing you must know that again the catalyst you can classify. Wait, one more slide I want here. See, so again the catalyst you can define as, first brother tell me, catalyst are going to increase or decrease the rate of reaction? कैटलिस्ट क्या करते हैं? रिएक्शन के रेट को बढ़ाते हैं या घटाते हैं? कैटलिस्ट आर गोइंग टू इंक्रीज और डिक्रीज द रेट ऑफ रिएक्शन? प्लीज टेल मी एवरीवन बेटा, कैटलिस्ट क्या करते हैं? व्हाट इज द मेन वर्क ऑफ कैटलिस्ट? कैटलिस्ट गोइंग टू इंक्रीज और डिक्रीज? प्लीज बेटा एवरीवन टेल मी. Catalysts are going to increase rate of reaction or decrease rate of reaction? Alter the activation energy, can increase, decrease, both, but generally increases according to the requirement. Both, can do both. Very good, fantastic beta. So catalyst can increase or can decrease. Okay. So on this basis, catalyst again can be defined as positive catalyst and negative catalyst. Can you tell me positive, negative, which one is going to increase the rate of reaction? इसमें से rate of reaction को बढ़ाता कौन होगा? ओके बेटा, वेरी गुड. रशियान मुखर्जी, विष्णु, कियादा, सुस्मित नंदी, नीरज कुमार, एवरीवन बेटा, वेरी गुड, फैंटास्टिक. नाउ टेल मी, आउट ऑफ these two, who is going to increase the rate of reaction? Positive one, fantastic. So this is going to increase, rate of reaction increases if you are using positive catalyst. And if, my dear students, you are using negative catalyst, then it is going to decrease rate of reaction. It is going to decrease rate of reaction. Positive catalyst है बेटा तो rate of reaction बढ़ेगा, negative catalyst है तो rate of reaction घटेगा. Okay. Now please tell me one thing beta. For same reaction, if I am using positive or one time and one time negative catalyst, for same reaction, and for this case definitely the activation energy value is not same. So suppose here the value is ea plus and here the value for same reaction is ea minus. Just tell me, ea plus, ea minus, which one हायर वैल्यू, हैविंग हायर वैल्यू, इसमें से ज्यादा वैल्यू किसकी होगी, ई ए प्लस या ई ए माइनस? सेम रिएक्शन, first time you are using positive catalyst and one time you are using negative catalyst. So I'm asking ea plus, ea minus, which one is larger one? Which one is larger one? Be careful, which one is larger one? Please everyone tell me beta. Neeraj Kumar, negative. Okay, everyone, I want answer from every student. क्या बात है भाई, बहुत ब्रिलियंट हो यार आप लोग. एवरीवन इज सुपर ब्रिलियंट, नॉट अ सिंगल रॉन्ग आंसर यार, नॉट अ सिंगल रॉन्ग आंसर. वेरी गुड बेटा. देवर्ष अग्निहोत्री, विष्णु, सुष्मित, नैंडी, धीरज कुमार, श्यान मुखर्जी, प्रशांत, क्या बात है, फैंटास्टिक फैंटास्टिक. सो क्लियरली in this case ea minus will be more than ea plus. Now if you want to represent here, and suppose uh, on this slide i am giving this for positive catalyst, this color for positive catalyst. So positive rate of reaction increases, see, they are going to change reaction path beta, see. And now this is clearly you can see beta, this is your new ea, this is your ea plus, this is your ea plus. Okay, this is your ea plus. So they decreases the value of activation energy. Clearly you can see now short path is there. Short path means easily they can get, reactants can get that energy and easily they can form their activated complex followed by respective product. This is activated complex. Uh, this point is known as reactant. If present here, it is known as activated complex. Soon I will tell you about activated complex theory, then you will get details about this activated complex. Okay. Now in the similar manner, my dear students, in the similar manner, if I am using this green color for my negative catalyst, फॉर माई नेगेटिव कैटलिस्ट, कैटलिस्ट एक कांस्टेंट लिख दिया रे क्या, कैटलिस्ट बोल के कांस्टेंट लिख दिया क्या. सो येलो इज फॉर पॉजिटिव कैटलिस्ट and green for negative catalyst. Now what they are going to do, they are going to increase, see आपने अभी अभी बोला ना increases, yeah increases. So they are going to increase the value of activation energy, and now they are changing path like this. See see my dear students, this time what happens, this is E minus. So clearly they are increasing the path, ये path को बढ़ा रहा है. So definitely they are going to slow down the chemical reaction. So if you are using positive catalyst, they will increase the speed of reaction. They will increase increase rate of reaction or reaction rate. And my dear students, if you are using negative catalyst, then they will decrease reaction rate. And definitely, mostly in chemical industry, you want to increase reaction rate. Only if some reaction is uncontrollable, like nuclear reactor fission reaction type, some reaction is there, then you want negative catalyst. Otherwise everywhere we want positive catalyst only. Okay, that means catalysts are going to increase the rate of reaction. This is a general line. Why? Because this is a general line for positive catalyst, because we use just positive catalyst mostly. So positive of complete clear accurate line is positive catalysts are responsible to increase the reaction rate at the same temperature. You can change reaction rate by changing temperature, but still if you are not going to change temperature for same temperature, positive catalyst can increase the rate of reaction. In Hindi if you want to feel बेटा, आप टेम्परेचर को मत बदलो, उसी टेम्परेचर पर रिएक्शन की रेट को बढ़ाना चाहते हो तो पॉजिटिव कैटलिस्ट वहां पे डाल दो. सेम रिएक्शन सेम टेम्परेचर, लेकिन रिएक्शन का रेट बढ़ जाएगा अगर आपने वहां पॉजिटिव कैटलिस्ट को डाला हुआ है. ओके, सो प्लीज वन मोर टाइम एवरीवन कंफर्म मी, इज इट क्रिस्टल क्लियर टू ऑल ऑफ यू माय डियर स्टूडेंट्स? कैन वी प्रोसीड बेटा? कैन वी प्रोसीड? नो डाउट्स एट ऑल? सी this activation energy concept given in 1889, in 1889 by S. Arrhenius, Swedish astronomer, chemist, physicist. Real picture taken from Google by me. So see definition clearly, just already discussed by us. So it is defined, it is defined as the least possible. Why it is least possible? Because if we are going to give energy more than this energy, still reaction is going to happen. But this is the final, you can say, critical point. इसके before reaching to this critical point, reaction will not get started even if effective collisions are there. इस एनर्जी को पाए बिना, जब तक ये क्रिटिकल पॉइंट तक ये मिनिमम अमाउंट नहीं मिलेगा, रिएक्शन स्टार्ट नहीं होगा अगर आपका इफेक्टिव कोलिजन है उसके बावजूद. सो लीस्ट पॉसिबल, इससे ज्यादा दे रहे हो, इफ यू आर गोइंग टू प्रोवाइड मोर देन दिस वन, स्टिल रिएक्शन इज गोइंग टू हैपन. बट दैट इज अ क्रिटिकल पॉइंट, उतना तो होना ही चाहिए, एटलीस्ट दैट अमाउंट ऑफ एनर्जी मस्ट बी देयर above their average energy of reactant. So that's why you're writing it is defined as the least possible amount of energy over reactants average energy, which is required in a chemical system for a reaction to take place. I hope everyone is crystal clear about this definition. So please write this in your notebook, and after writing, if definition is also crystal clear, then please write done in comment section, then we will move forward बेटा. फटाफट लगातार बताते रहा करो. एवरीवन प्लीज टेल मी, कम्युनिकेट विद मी जस्ट लाइक ऑफलाइन क्लास. यार जैसे ऑफलाइन क्लासेस में कम्युनिकेट करते हैं ना लगातार हर एक के बाद, प्लीज टेल मी बेटा इज इट क्रिस्टल क्लियर? सो जस्ट लाइक दैट बेटा, आई वांट reply from your side after every slide. Okay, so please one more time beta, please everyone tell me, is it crystal clear to all of you? Can we proceed beta? No doubts at all? Everyone feeling comfortable? Super mind blowing. Can we proceed? प्लीज नोट डाउन बट इट इज इसको नोट करने के बाद बोलेंगे. एवरीवन प्लीज टेल मी. कैन वी प्रोसीड? Still waiting for your comments. डन सर. ओके बेटा. बहुत अच्छे. नाउ unit of reaction rate constant. Next heading is unit of reaction rate constant. Everyone please note down. Unit of reaction rate constant. You know, you can define Ra, that is minus Ra, reaction rate, on different basis. Okay. So if basis, that means on which basis you are going to define rate of reaction, is basis fixed, then unit will also fixed, and it is more accurate if you are telling instead of this unit dimension. Okay, because maybe you are going to represent volume in meter cube, maybe you are giving volume in liter. Okay, so basis fixed, then unit will also fixed, but for a given reaction, that means beta, if reaction sorry, for a given reaction order, if you are going to change reaction order, the rate constant, then unit of rate constant k will also fix. The rate constant unit will be fixed for a given reaction order if the basis is fixed. Basis you are going to change, like from unit volume you are going to change unit surface of the solid, then definitely unit will be changed, dimension will be changed. More accurately you can say dimension will be changed. How? I will show you later. But first I will deal for general case, like the Ra. General unit is mole per meter cube per second. This is general unit. That you can use for Ra. The general unit that you can use for Ra, rate of reaction. Okay. Now, just I want to do one analysis by taking different order reactions. What will happen with unit of reaction rate constant? Okay, unit of reaction rate constant. So this Ra clearly is not going to depend upon order of the reaction. So Ra unit is fixed for any order. Suppose this unit is given like mole per meter cube per second, or mole per meter square per second, or mole per kg per second, based on different basis. Suppose here basis I am taking based on unit volume. Suppose example I am taking here unit volume basis. Unit volume of reaction mixture. Suppose I am taking this as my basis here, beta. Okay. So what just I told you, that for this given case, the K, that is known as reaction rate constant, or simply it is also known as और रेट कांस्टेंट, सिंपली इट इज आल्सो नोन एज रेट कांस्टेंट। बेटा इसे रेट कांस्टेंट के नाम से भी जाना जाता है, रिएक्शन रेट कांस्टेंट के नाम से भी जाना जाता है, वेलोसिटी कांस्टेंट के नाम से भी जाना जाता है। सो व्हाट इज के इज रेट कांस्टेंट हियर, के इज रेट कांस्टेंट हियर। सो unit, its unit is strongly strongly a function of order of the reaction, a function of order of the reaction, order of the reaction. Okay, so now I'm taking one by one different order reactions, and I want to check the unit there. What is the unit for that given case? Like suppose, my dear students, we have a typical case, first order reaction. We have a typical case of first order reaction. So please write down the first one is first order reaction. First order reaction. Okay. Now I want to do analysis for this beautiful reaction here. So suppose first order some reaction is forming R is there, and its rate expression is given as Ra is equals to Kca. Kca. Okay. Definitely the concentration for all of these cases, concentration. If you want to write the unit of concentration, then the concentration I am taking in mole per meter cube, because clearly here you are writing mole per meter cube per second. So this is concentration, mole per meter cube. Okay. So here the unit of Ra, mole per meter cube per second. The unit of concentration, mole per meter cube. So my dear students, simple unitary rule type technique you can use here. So unit of K will be written as unit of Ra upon unit of Ca. So my dear students, here for this case it will be mole per meter cube per second and whole upon mole per meter cube. So clearly after solving you are getting 1 by second, that means second inverse. Second inverse. So this is the unit of reaction rate constant for first order reaction. For first order reaction. Now can we do a same analysis for some other order? Yes. So please write the second one, but a second order reaction. फटाफट इसे कर लें. Very easy. These things are also very easy. So second order reaction. Second order reaction. Second order reaction. Now please focus here, my dear students. If you want to do the same analysis for second order, why you are worrying here? Again you can write the same Ra, but this time beta it should be Kca square, because you are writing second order reaction. And now in similar manner beta you can write the unit of k as unit of Ra and whole upon unit of Ca square, not Ca, it's Ca square, unit of Ca square. So how to write? What is the unit of Ra? It's mole per meter cube per second. What is the unit of Ca? It's mole per meter cube, but it's Ca square. So two times you have to write mole per meter cube. Now mole, meter cube cancelled. What we are getting? We are getting 1 by second by mole by meter cube, that is meter cube per mole per second. Or further you can write like this: meter cube mole inverse second inverse. Are you getting my words beta? Please everyone tell me, is it crystal clear to all of you? Can we proceed beta? Please everyone tell me beta, can we proceed? First order, second order, both crystal clear to all of you? Mole inverse. Done beta, can we proceed? So in the similar manner beta, you can also do analysis for third order reaction or for any zero order reaction. Like suppose we have a third order reaction. See, two more times I want to do this third order reaction, and this time I want this analysis from your side. Please everyone obtain the reaction rate constant unit in this by using similar technique by for this third order reaction. Okay, and as well as beta, please do this for me if the order of the reaction is zero, that is zero order reaction. zero order reaction, zero order reaction. सो इन दोनों के लिए करोगे, आई एम ऑल्सो डूइंग, बट प्लीज डोंट सी माई स्लाइड, आप मेरी स्लाइड को मत देखें, प्लीज डू इंडिपेंडेंटली। एंड आफ्टर कंप्लीटिंग जस्ट कंपेयर योर यूनिट विथ माई यूनिट। ओके, कंप्लीट करने के बाद से आप अपनी यूनिट को मेरी यूनिट के साथ मैच करोगे, देन जस्ट टेल मी आर यू गेटिंग सेम टू सेम और डिफरेंट आंसर। प्लीज एवरीवन जस्ट चेक योर यूनिट्स एंड टेल मी इज इट सेम, क्या आपको यही मिला है और डिफरेंट मिला है। सेकेंड इनवर्स मोल पे -2 and meter to the power 6. Is it same to same? Please everyone tell me. Oh my god, here the unit of K directly mole per meter cube per second, because it is the unit of directly Ra. Okay, same. Very good, very good, beta. Now wait, one more slide I have to add here. Oof, cancel. अरे भाई एक मिनट रुक जाओ बेटा, स्लाइड सेव कर लेने दो। Okay, now same, very good. Now, is there any relation that we can develop for any order reaction like nth order reaction here? So here clearly this can be represented as concentration raised to power 0 and second raised to power -1. And here my dear students, you can see it is nothing but concentration raised to power -1. See, mole per meter cube is in denominator. And again the second raised to power -1. Here if you are seeing beta, this is nothing but concentration raised to power mole per meter cube, see in denominator, so it's -2, and second raised to power -1. Similarly here if you want to write beta, it is concentration raised to power 1 and second raised to power -1. So is there any relation present between these all? Yes, see, this is -2, this is 1, this is -2. So if I am writing like this, that unit of rate constant for this general case, if the volume is there, okay, based upon volume, so unit of rate constant, if some other basis is given, then just follow these fundamentals techniques to get the unit of reaction rate constants. So here unit of rate constant is clearly in all these cases, you can see time inverse is there for all these cases, but you can see here also time raised to power -1 is present. Here also time raised to power -1 is present. Here also time raised to power -1 is present. Here also time raised to power -1 is present. Okay, so time raised to power -1 directly we can write that time raised to power -1 is there. But what should be power? What should be power upon this concentration term? So we have to check. See, when zero order it's 1. So concentration raised to power 1 minus something or n minus 1. If we are getting n minus 1, then n is equal to 0, it will be -1. So here we are getting like 1 minus n. See, okay, satisfied. But let me check here also. Concentration 1 minus n, 1 minus 3 is -2. Yeah, very good. Let me check here also. Concentration raised to power 1 minus n. So first order 1 minus 1, 0. Yeah, satisfied. Let me check here. 1 minus 2 minus. Oh my god. Absolutely correct. That means, my dear student, here you can write concentration raised to power 1 minus n. So this is the general expression for unit of reaction rate constant for nth order reaction if the basis is unit volume. Basis is unit volume. Can we develop it by assuming nth order reaction? Yes, beta. See. Suppose I am telling this time nth order reaction. I am telling nth order reaction. This time, beta, I am telling nth order reaction. What is going to happen here? Just focus here. This time the rate expression can be written as minus RA and that becomes equals to beta K CA raised to power n. ध्यान से देखेंगे बेटा everyone just focus here. If any doubt then just ask me. Still we are in easiest part of CRE, starting of CRE, just in fundamentals. Still here we are in fundamentals. We are able to solve lots of PIQs. See this number of PIQs and many more. But in today's lecture, based upon time इतने को हमने लिया. बाकी भी आपको I will show in my next lecture. I will show more PYQs based upon our completed lectures. Okay, so R is equal to K C A raised to power n. So here if you want to write the unit of K, then it is the unit of RA upon the unit of concentration raised to power n. Now the unit of RA is mole per meter cube per second. Okay, and whole upon the unit of concentration mole per meter cube raised to power n. Now clearly here you can see beta, you can write it mole raised to power, this is 1, and this if you are writing in numerator minus n, so it is 1 minus n, and second raised to power minus 1. So what is mole per meter cube beta? This is concentration term, this is seconds. So in this manner you can also write what is the unit of reaction rate constant K for any given order reaction. What is n here? N is order of reaction. N is order of reaction. So please tell me beta, is it crystal clear? Can we proceed beta? Are you ready to solve PYQs? क्या आप PYQs solve करने के लिए तैयार हो बेटा? फटाफट बताओ बेटा. Few basic PYQs I want to show you. Few basic PYQs I want to show you. Everyone please tell me, and beta please be careful while giving answer because it's still easiest PYQ that you are going to see because just from fundamentals, just the fundamentals that completed by you. Okay, so many PYQs still you are able to solve. So everyone ready? See problem number 7, 1 mark question, GATE 1999, and don't see this 2 minute timer. Max time I am allotting you 1 minute. 1 minute है आपके पास. Tell me answer. You have 1 minute. Tell me answer, beta. Everyone, please tell me answer. Last 15 second approx. Tell me what answer. Very good, very good. So everyone getting D. Absolutely correct, but a D is the right answer. So overall order of reaction for which reaction rate unit mole per liter. Okay, so here clearly you can see beta, it is concentration raised to power minus 3 by 2 and second raised to power minus 1. If you are going to compare this with general unit of 1 minus n and second raised to power minus n beta, then you will get 1 minus n is equals to minus 3 by 2. So n if you're writing here, so n is equals to 1 plus 3 by 2. So n will be 5 by 2. Very good beta. So D is the right answer. Absolutely correct. बहुत अच्छे. Now see, very very easy question. So GATE 1995. Please tell me beta. The dimensions of rate constant for reaction discs are liter per gram mole per minute. Therefore the reaction order is 50 second still left. Max time allotted 1 minute. Hardly this question will take few seconds here. A, B, C, D. Which one is correct? I use C. Okay, beta. Wait, because Kiada is getting A, Prashant Kumar getting C. So two types of answer this time here. Divash Agnihotri C. Okay. So now mostly students getting C now. अभी C ज़्यादा बच्चों का आने लगा. Okay. Okay बेटा मेहनत दिव्यांश ऋषि सुशैन नेहना ऋषि हुसैन भोगी शाही कुमार दिवर्ष सुस्मित नैंडी क्या बात है बेटा एवरीवन नाउ गेटिंग सी ओके लेट मी चेक यार let me check here written the dimensions of reaction rate constant that means for K it is given liter per gram mole per minute so gram mole I can write like just mole and into minute so clearly this I can write like 1 upon mole per liter per minute or I can write like here mole per liter this is concentration term raised to power minus 1 and minute raised to power minus 1 this is concentration term so now beta I can write 1 minus n as minus 1 here so 1 minus minus plus 1 is equals to n beta it's 2 ओके बेटा जल्दी जल्दी में लगा एक एक ऐसे काट दिया होगा पहले हैं किया दास हाँ पहले आपका ए ऐसे आ गया होगा जल्दी में मत रहा करो बेटा आराम से किया करो okay so which one is correct my dear students C is the right answer. Okay, okay, don't worry. Again, you are getting chance. So C, again, max time is 1 minute. Please tell me answer. For reaction P plus 2Q forming TR, molar rate of consumption of P is. Yes, sir. Okay, beta kya das. Now tell me answer of this question. For this given reaction, please be careful. Please, beta, don't do silly mistakes. Silly mistakes nahi karenge. Tell me answer. Very good, very good. Very good. See, sir. Okay, let me check here that you are correct or not correct. Okay, let me check. So, reaction P plus 2Q forming 3 molar rate of consumption of P is related to Q. If Q here 20 kilomole consumed, then with respect to this 20, it will consume 10. So, the molar rate of consumption of P clearly half that of Q. So, half, yeah, fantastic. C is the right answer. बहुत अच्छे बेटा सी प्रॉब्लम नंबर 10 वेरी इजी नो नीड ऑफ एनी टाइमर टाइमर की रिक्वायरमेंट भी नहीं है प्लीज टेल मी ABCD immediately you have to give answer ABCD which one is correct beta B molecularity of elementary reaction so clearly A 1 and 1 2 so molecularity of the reaction is 2 okay fantastic if non-elementary written then you have to write undefined you are unable to define it need more data and you can define just for a given step okay so you can't define molecularity of that reaction okay so gate 1999 similar type of question already we solved so again but I want answer from your side and because already solved similar question so I'm giving you 30 seconds tell me ABCD okay beta Shyan Mukherjee Kyadash Mehna Susmit Ayush Devarsh Agnihotri Divyansh this time tell me beta ABCD which one is correct 30 second, 10 second left. Very good, very good. So clearly A plus B, that means their respective rate of reaction is related like RA by 1 is equals to RB, stoichiometric coefficient of B is 1. So minus RA is equals to minus RB, as I told you, for these type of questions you can use this minus as subtraction sign. So which one is correct? Clearly A is the right answer. Okay, so this type of question already asked, discussed by me. So please tell me. See, GATE 2003 one mark question asked. For a series reaction A is forming B is forming C, having K2 is much higher than K1, the reaction system can be approximated as. सुस्मित नंदी कौन सा है? अरे नो, अरे अरे वेट 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 वेट, ये तो हमने देखा ही नहीं, इस साइड तो देखा ही नहीं यार, वेट वेट वेट, सॉरी, ये तो हमने देखा नहीं इधर का ना, एक मिनट रुक जाओ, लेट मी चेक वन मोर टाइम, let me check one more time here. This is B also here, I'm writing B also here. So A plus B forming 2B plus C. What is the relation between RA and RB? So कैसे बनाओगे इसके रेट एक्सप्रेशन को? Because this is the reaction like A plus B and it is going to give you B plus B plus C. This is the reaction. This is the reaction that you are writing here, beta. ओके, ये है आपका रिएक्शन. नो नो नो, जिसने भी सबने ये बताया ए नहीं होगा बेटा, ए नहीं होगा इसका आंसर. ओके, ए इसका आंसर नहीं होगा. सी बेटा, दिस इज अ स्पेशल टाइप ऑफ रिएक्शन दैट यू विल सी इन माय सब्सिक्वेंट लेक्चर, दैट इज नोन एज ऑटो कैटालिटिक रिएक्शन. ऑटो कैटालिटिक रिएक्शन, ये एक तरह का ऑटो कैटालिटिक रिएक्शन है in which B is acting like a catalyst. So B is still there. B will be cancelled both sides. So this reaction can be written as A is forming B plus C. This is the reaction, beta. So clearly here RA by 1 is equals to plus RB by 1. So the right relation is minus RA is equals to plus RB. Or you can write beta RA is equals to minus RB. या बेटा बी इज राइट आंसर. ये हमने देखा नहीं था, डोंट वरी. आप भी नहीं देखे, ऐसा क्यों करते हो यार, आपको तो देखना चाहिए ना. इज इट क्रिस्टल क्लियर टू ऑल ऑफ यू? इज इट क्रिस्टल क्लियर बेटा वाई बी इज करेक्ट? प्लीज टेल मी एवरीवन crystal clear so that we can move forward. Okay, crystal clear. Now please tell me this one beta, A B C D, which one is correct? A is forming B is forming C, having K1 much less than K2. K2 is much higher than K1. The reaction system can be approximated as. GATE 2003 one mark question. Tell me beta everyone. D, okay, okay, D, crystal clear sir, okay बेटा. D, this time श्यान मुखर्जी B होगा सर. इसका B बोल रहे हो कि पिछले वाले का B होगा? किसका B बनाना चाहते हो रे भाई? D, mostly students giving answer D. बेटा श्यान मुखर्जी, whose answer is, tell me for this one, A B C D. Tell me again so that I can feel which question answer you are giving here. Problem number 12. Okay, so you are telling sir B hoga. Okay, let me check beta. A is forming B is forming C, having K1 much lower than K2. That means this one is higher one. This side, this reaction rate is very high, this reaction rate is very low. So A is forming, this is very high. So as soon as B is created, it is going to convert it into C because reaction rate B to C is very high. So here you have to write C, and rate is controlled, overall rate is controlled by slowest step, and that is represented by K1. So I have to write here K1. So beta, here the answer is T. Here answer is D. No beta, Shyan Mukherjee B nahi hoga beta, answer D hoga. Okay beta, is it crystal clear to all of you? Is it crystal clear beta? Can we proceed? For a series of reaction system can be approximated as. The complete reaction study that you are going to see here, controlled by lower value of reaction rate constant and final product, that is CR manufactured. Crystal clear sir? Okay sir, okay. So problem number 13 asked GATE 2004 one mark question. For this question, I am giving you 1 minute. Solve this, beta. Come on, everyone, beta. Come on, solve this. ओके बेटा टाइम अप. अरे यार ये क्या हो गया रे भाई. ये लग रहा है मिसप्रिंट हो गया. वेट वेट वेट. ये तो रिएक्शन ही गड़बड़ हो गया रे भाई. वेट वेट वेट. आई एम राइटिंग करेक्ट रिएक्शन यार. So my dear students, correct reaction is N2 plus 3H2 forming 2NH3. Now please solve it. अभी सॉल्व करो. Timer resumed. 12 का C A2 है. नो बेटा 12 का D. 12 का D लिखोगे बेटा क्या दास. 12 का D लिखोगी. ओके. Slowest step is K1. Tell me this one. A, B, C, D. 13 का B. Tell me everyone beta. Ayush telling sir A. Okay Ayush. Please beta everyone tell me. Vishnu A. Okay beta. Give me answer little bit faster way. Susmit Nandi don't know sir. Divash Agnihotri A. So mostly students giving answer A. Okay. So the right answer is not A. Okay, why? See, if you are writing A plus B forming R, and if rate expression, suppose I am writing like K C A C B, and if I am writing this reaction like 2A plus 2B forming 2R, so the rate is going to expression is going to R K C A square C B square. No beta. Rate is an experimental quantity. Order is an experimental quantity with respect to component or overall experimental quantity. So just by changing stoichiometry by your hand, by dividing complete equation or multiplying some uh, same factor with to complete equation, the rate expression here not you can't change. ये कैसे बदल जाएगा रे भाई? It is not going to change. So even if this is writing like 1 by 2 and 3 by 2 and here NS3, still the rate expression will remain same. So C where is same C? B is same. B is same. So which one is correct, beta? B is the right answer. Is it crystal clear to all of you? Tell me, beta, Vishnu, Devarshagni, Hotri, Ayush, and all those given option A. So A is not correct, beta. You can't change order of reaction. You can't change rate expression by changing a stoichiometry of reaction by some multiplication of common factor to all reactant and or and products. Crystal clear, sir. Okay. Fantastic. So now one more question. Asked GATE 2015. Uh, one more question. The rate expression for the reaction is given by minus RA K1 CA square upon 1 plus K2 CA half. The units of K1 and K2 are respectively. Please tell me बेटा everyone. ये दोनों सेम हो गया क्या? ये A और B सेम ही लग रहा है ना? हाँ, ए और बी सेम है, कोई बात नहीं, कोई बात नहीं, आप बताओ। एक हम अलग कर देते हैं, ये हम माइनस लगा देते हैं, अब बताओ। वेट, लेट मी स्टार्ट टाइमर, 2 मिनट, कंप्लीट 2 मिनट इज देयर फॉर यू। प्लीज सॉल्व दिस बेटा, जल्दी से लगा दो इसे, कम ऑन एवरीवन। लास्ट 1 मिनट बेटा। 40 सेकेंड लेफ्ट। ओके, सो यू आर गेटिंग बी। वेरी गुड बेटा सुष्मित नंदी, वेरी गुड शियान मुखर्जी। आई थिंक बी वॉज द राइट आंसर, बी ही सही है जहां तक हमें याद आ रहा है। सो रेट एक्सप्रेशन इज गिवन हियर, सी बेटा। So K1 CA square. Clearly in denominator, the unit of this 1 and this will remain same. So this K2 CA half will be unitless. It will be unitless. And the unit of K1 CA square will be having unit of this RA, and if nothing mentioned from your side, the conventional unit that you are taking mole per meter cube per second, because in all of these in A, B, C, D, all options you can see nothing like liter is present. Everywhere meter present. That means the concentration you are taking mole per meter cube, because mole and meter is there. So now what is the unit of K1? How to write it? So unit of K1 will be mole per meter cube per second, and here into Ca square unit. So it can be written as mole per meter cube per second. And what is Ca? So Ca is mole per meter cube, and Ca square, so whole square. This will be cancelled. Okay. So here you will get meter cube per second and per mole. Okay, meter cube per second per mole. So see, in option B, meter cube per second per mole. Yeah, okay, satisfied. Now let me check for this K2. अभी इस K2 के लिए देखेंगे. So unit of K2 will be 1 upon unit of C raised to power half. So what is the unit of Ca? It's mole per meter cube. So it's raised to the power half. So further you can write like meter cube and 1 by 2. So it's 3 by 2 and into mole raised to power minus 1 by 2. So mole raised to power minus 1 by 2, meter raised to power 3 by 2. Oh, very good बेटा, आप सभी लोग सही हो, absolutely correct बेटा. So B is the right answer. Please everyone tell me, is it crystal clear? Can we proceed बेटा? Can we proceed? जल्दी जल्दी बोलो बेटा. Come on everyone, tell me. Can we proceed? Is it crystal clear to all of you? Done? Done sir? Okay, okay. See, problem number 15. No timer required for this. Please everyone tell me which one is correct. This is CJ. C subscript J. This is NJ. NJ. Okay, tell me. Tell me which one is correct. A, B, C, D. A, B, C, D. Done, sir. Okay, please tell me. For this one, beta. Everyone, come on, everyone, tell me which one is correct. A, B, C, D. A, B, C, D. Which one is correct? Don't know? Then write R in comment section. If no, then please give me your answer. Kya das? Fantastic. But maybe you are correct or not correct, I don't know. I will tell after 10 seconds. Divyan's D. Kya das? C. Okay. बेटा जल्दी 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 आंसर दिया करो everyone please. Respond quickly. Decrease the value of time constant of your mind so that the speed of response increases. Okay. So Syan Mukherjee B. Shushit Nandi A. Vishnu D. Divas D. Only Kia Das is C. Other students telling A, B, D. That means for this one, A, B, C, D, all you are telling. So, my dear students, the most accurate answer for this is C. Because you know I is for reactant in conventional form and J is for product. Okay, so if product is there, then 1 by V, D and J by dt. This is the rate of reaction. So C is correct. But the same question, if they are going to ask in GATE 2026, then don't worry, D will also be correct there. Mostly chances are there that they can correct both. Okay. Otherwise, they have to give J represent product. उनको दिखाना पड़ेगा J represent product. Okay. But more accurately here, beta, you can see this C is correct. Now, why this A is not correct? You are writing 1 by V d and j by dt, and few students telling sir a, yeah, a is can also be possible. See, d and j by v by dt, so clearly it is d cj upon dt, moles per unit volume. But my dear student, this is not possible every time because this v is not constant everywhere. This is possible only for constant volume reactor. Constant volume reactor. If variable volume reactor system, then it is not possible. Then you can't write like this. Then this V can be written as V is equal to V naught 1 plus epsilon A X. You will see later for variable volume reaction system. You will see this V as V naught 1 plus epsilon A X. So you can't write like this. ओके सो इसलिए आप ऐसे अप्रॉक्स कर सकते हो, केवल एक गिवन केस के लिए हमेशा नहीं कह सकते. दैट इज नॉट अ कन्वेंशनल वन. Okay, so the most accurate is only C because this is also correct, but only correct when constant volume reaction system. That means when epsilon A is 0. Like here you are writing epsilon A is 0, then V is equal to V naught. No need to worry. Okay, so in that case this is correct. But this C is correct always. This is always correct. This is always correct. Variable volume system or constant volume system, it doesn't matter. Okay, but please tell me everyone, is it crystal clear to all of you? Is it crystal clear, beta? Everyone, please tell me. Shian, Susmit, Devash, Vishnu, Aman. Everyone, please tell me. Can we proceed, beta? Jaldi jaldi batao. Crystal clear, sir. Okay. So see one more question. An irreversible homogeneous reaction A's formed product has the rate expression rate is equal to this, where Ca is the concentration of A. Ca varies in the range of 0.5 to 50 mole per meter cube for very high concentration of A. The reaction order tends to. Please tell me answer, beta. A, B, C, D. Which one is correct? Which one is correct? Please, everyone, tell me. Which one is correct? Tell me, beta. Come on. So Divyans B, Aman D. Okay. Okay, beta. I'm not giving too much time for these questions because very very easy questions are there. Okay, so they were Three B. B. Students deleting their messages and changing answers. Now all students giving B, 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 B. Everyone is giving B now. अभी सब लोग B के ऊपर में आ गए. Okay. So an irreversible homogeneous reaction is forming product has the rate expression this. Ca varies in this. very high concentration. Very high means suppose in this range I'm taking is 50. Then 50 Ca, 50 Ca, 1 plus 50 Ca can be written as 1 plus 50 into 50, that is 1 plus 2500. So clearly it can be written just as 2500 for this case. So my dear students, a very high concentration, then 1 plus 50 Ca can be approximated as just 50 Ca when if Ca is very high. Okay, same to same in numerator beta, c 2 Ca square, so 2 into Ca squared 50 square, that means 2500 plus zero point 0.1 into 50. Ca is max value, I'm writing 50, so here this is 5000 and this is only at only 5. So clearly I can approx it as 5000. That means I can approx 2 Ca square plus zero point 0.1 Ca just as 2 Ca square. Now by using these two approximations, what will we get? Now I can write this rate expression as only 2 Ca square and whole upon only 50 Ca. So it will come 2 by 50 into Ca only. Ca will be cancelled this square. So clearly the order of the reaction tends to 1. Congratulations, B is correct. Okay बेटा, बोलो बेटा सभी को क्लियर है? एवरीथिंग इज क्रिस्टल क्लियर? नो डाउट्स टिल नाउ? Please everyone tell me beta, no doubts. So see one more question and this time I think that's enough for today's lecture. So this is your beautiful homework that I am giving you. Please solve this. I will discuss at the start of next lecture beta. For a gas phase reaction at 400 Kelvin, the rate is represented at minus d Pa by dt is equals to 3.66 Pa square and the unit is atm per hour. This rate expression is given along with your question. Okay, minus dB by dt is equal to 3.66 Pa square atm per hour. Now what are the units of rate constant? Unit of rate constant, यहाँ unit बतानी है rate constant की unit क्या होगी. Then what is the value of rate constant? Now value आपको बताना. Now you have to tell value. If the reaction is represented as 18 number minus Ra is equals to minus 1 by V d Na by dt, and now here just in place of Pa I am going to write Ca square. So is equals to K Ca square. In this, what is the value of this K? And again if I am writing this as same to same here, again I am writing same to same, minus 1 by V d Na by dt is equals to Kca square. But what is the difference between these two? In the both cases, the unit of reaction rate constant is not same. Like in above one, I am writing mole per liter per hour. Here it is mole per liter per hour. And here, my dear students, it's mole per meter cube per second. So very good question. I want answer from your side. So this is your homework, beta. Okay. क्रिस्टल क्लियर बेटा? कर लोगे इसे? टेक अ स्क्रीनशॉट. यूट्यूब पर है, अभी लेक्चर ओपन है, फ्री है सभी बच्चों के लिए. सो अभी आप इसको स्क्रीनशॉट लेकर के रख लो. ओके. नाउ at last I want to show that slide. If you want beta rank 1 to rank 100, then don't forget to revise your notes every day beta. Revision is the key for success for your dream job. I must do my vision daily. 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 Okay beta, take care, all the best, a very happy good night to all of you. एंड बेटा प्लीज टेल मी एवरीवन एंजॉयड सर. बहुत सभी लोग बताओ बेटा, सभी को एंजॉय लगा? सब लोग, ऑल कॉन्सेप्ट्स आर क्रिस्टल क्लियर टू ऑल ऑफ यू? एवरीवन प्लीज टेल मी. एंड माय डियर स्टूडेंट्स, न्यू स्टूडेंट्स हु वांट टू टेक एडमिशन, ओके, जो सारे सब्जेक्ट लाइव देखना चाहते हैं इसी तरीके से फ्रॉम मी एंड many more top educators of India here in EII, then beta don't forget to join as soon as possible beta to secure your dream rank in gate 2026. Just call me 9451707049. You can call me, you can WhatsApp me. If you want to talk with our Rajesh sir, director sir, then number is also there. नीचे देखो एक पट्टी चल रही होगी, उसके ऊपर में नंबर दिया हुआ है। डायरेक्टली एडमिशन लेना है, हमसे भी बात कर सकते हो। The discount that is applicable at that time, I will try to give you the max amount there. Okay, so offer is little bit offer is going on. If you are going to join, definitely you will get some discount this time, so don't forget to join as soon as possible, beta. All the best, beta. Take care, love you all. For more details about courses, you can call me, WhatsApp me. Take care. Okay, fantastic. Practice sets question I will discuss in live doubt link session, beta, only. Okay, so all the best, beta. Take care, love you all. No doubts. Okay, sir. Take care, beta.